Hi everyone! Today, we're diving into a powerful technique for embedded systems, sending data through SPI using direct memory access, or DMA. This combination is super efficient and can make your projects much faster. We'll explore what SPI is, what DMA does, why they're a perfect match, and how you generally set them up to work together. First, let's talk about SPI. SPI stands for Serial Peripheral Interface. It's a fast, synchronous serial communication protocol. This means it uses a shared clock signal to keep data synchronized between devices. SPI typically uses 4 wires: SCLK for the clock, MOSI for master out, slave in, MISO for master in, slave out, and CS for chip select. The master device controls the clock and selects which slave device it wants to talk to. It's great for connecting microcontrollers to sensors, displays, or other peripherals over short distances. It's simple and very effective for many applications. Now, let's look at DMA. DMA stands for Direct Memory Access. Imagine your microcontroller's brain, the CPU, is constantly busy. When it needs to move data from one place to another, like from a memory buffer to an SPI peripheral, the CPU usually has to do all the work, byte by byte. This takes up valuable CPU time. DMA is a special hardware feature that acts like a dedicated data mover. It can transfer blocks of data between memory and peripherals, or even memory to memory, all without the CPU's direct involvement. The CPU tells the DMA controller what to do once, and then the DMA controller handles the entire transfer in the background. This frees up the CPU to do other important tasks, making your system much more responsive and efficient. So, why combine SPI with DMA? This is where the magic happens. Sending data over SPI often involves transferring many bytes, especially for things like updating a graphic display or reading a large sensor array. If the CPU has to manage each byte for SPI, it wastes a lot of time. By using DMA with SPI, the CPU simply sets up the DMA transfer. It tells the DMA controller, move this block of data from memory to the SPI data register. Then, the DMA controller takes over. It feeds the SPI peripheral with data as fast as the SPI clock allows, byte after byte, without bothering the CPU. This significantly reduces the CPU's workload. It allows for much higher data throughput. It also ensures consistent timing for data transfers, which is crucial for high-speed applications. Your CPU can then focus on complex calculations or managing other peripherals, instead of babysitting data transfers. This combination is particularly useful in real-time systems where every CPU cycle counts. Setting up SPI with DMA generally involves a few steps. Firstly, you configure your SPI peripheral itself. You set its clock speed, data mode, and data size, like 8-bit or 16-bit transfers. Next, you configure a DMA channel. You choose an available DMA channel and tell it the source address, which is where your data is stored in memory. You also specify the destination address, which is typically the SPI data register. You define the amount of data to transfer, for example, 100 bytes. You also set the transfer direction, which in this case is memory to peripheral. Then, you link the DMA channel to the SPI peripheral. This means you tell the DMA controller that this specific channel should be triggered by the SPI peripheral's data request. Finally, you initiate the transfer. This usually involves enabling the DMA channel and perhaps starting the SPI transfer with a single CPU command. Once started, the DMA controller takes care of moving all the data. When the transfer is complete, the DMA controller can often generate an interrupt to inform the CPU that the operation is finished. This allows the CPU to then process the next task or prepare new data. It's a powerful way to make your embedded projects perform at their best. Thank you so much for watching and learning about SPI with DMA. I hope this explanation helps you understand this crucial concept in embedded systems. If you found this video helpful, please give it a thumbs up, and don't forget to subscribe to the channel for more technical insights and tutorials. Your support helps us create more content like this.